scientists made a daring announcement, asserting that they have discovered a new planet unlike anything previously known. NASA, known for its revolutionary findings, has revealed that not only is this planet fascinating because of its location and size, but also because it projects light that seems to be made up of mysterious materials. Are we close to disclosing information that could improve our comprehension of the universe? This finding may indicate the existence of other planets with life. By exploring the amazing discoveries made by NASA, we may soon discover the truth about these extraordinary illuminations. In 2007, with the launch of the Dawn spacecraft, a mission to investigate some of the most fascinating planets and stars in our solar system, NASA made significant progress. Dawn had 3 ion engines and began its journey with a 14-month investigation into Vesta. Vesta is the second largest asteroid in the belt. Dawn sent back precise data and images exposing the intricate surface of Vesta and a wide range of geological history. After achieving its goal at Vesta, Dawn began the second and possibly most enthralling phase of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and move in a direction not possible with conventional chemical propulsion. These engines offered a gentle thrust that made it possible for Dawn to travel a considerable distance and enter a stable orbit around Ceres. Found in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the asteroid belt's largest object between Jupiter and Mars. For many years, it was thought to be the smallest dwarf planet in the solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres includes the largest and thickest structure in the asteroid belt, one of the most fascinating due to its unique traits. Scientists eagerly awaited the first complete images of this enigmatic world. What became clear were bright spots dispersed throughout its surface, particularly in a large crater known as a crater. These shining areas immediately sparked interest and speculation in the scientific community. Before dawn, the best image we had of Ceres was a low-resolution, blurry image taken by the Hubble Space Telescope. This tiny planet had very little known about it, and the possibility of finally receiving high-quality data promised great discoveries. The Dawn mission sought to enhance comprehension of the role of water in the solar system and the process by which planets are formed. The bright spots on Ceres were also seen on other asteroids and might be made up of reflective materials, salts that remain after water has sublimated. This finding raised the possibility of cryovolcanism on Ceres, a process where volcanic eruptions produce liquid water or brine rather than molten rock. But what exactly are these enigmatic lights? What clues do they provide about Ceres' character? They might also be evidence of ongoing geological activity or something even more exceptional. Ceres stands out among other bodies in the asteroid belt due to its size, mass, and composition, including the capacity to retain water and ice, unlike the typical rocky asteroids. Its comet-like composition suggests that it might reveal additional information about the early solar system. After traveling for 2 years, the Dawn spacecraft finally approached Ceres in early 2015, marking a significant turning point as it prepared to capture the first close-up images of the largest object in the asteroid belt. As Dawn got closer, images of Ceres increased in detail, revealing a previously hidden world. The initial images showed a surface covered in craters, indicating a long history of impacts. What caught the interest of researchers and space enthusiasts were the mysteriously bright spots in the pitch-black, rocky terrain. As image resolution increased, the scientific community formed theories about the nature of these shining spots. Were they ice patches reflecting sunlight, or something else? Some speculated they were mineral deposits, while others suggested signs of cryovolcanic activity. To everyone's surprise, a closer look revealed that there was not a single bright entity, but rather a collection of distinct spots. The most commonly accepted hypothesis is that these were deposits of salt created when water sublimated. This suggests that Ceres either currently has, or once had, geological activity capable of producing such phenomena. Brine or water reaches the surface area, where it rapidly evaporates, leaving behind brightly reflective traces. These findings challenged previously held beliefs about how Ceres operates, creating a picture of a more complex and dynamic world than previously imagined. The possibility of the existence of brine or groundwater pockets may have significant implications for our understanding of the potential for life in our solar system. Ceres is a fascinating dwarf planet, frequently described as a rocky world covered in ice. It has a porous surface, distinct from most celestial bodies that primarily consist of rock and metal. Ceres stands out for its unique composition. Its surface contains a combination of hydrated ice and water-based minerals like carbonates and clays, which contribute to its lower density compared to its mountainous neighbors. Ceres' composition suggests a substantial amount of water. Its surface layer is rocky, but it contains ice and is porous, with other volatiles trapped inside, making it more like a comet than a typical asteroid. This dwarf planet is thought to have a distinctive interior, with a muddy, ice-rich mantle and a water-rich core that represents approximately 50% of Ceres' volume. The mantle is likely a mix of brine and rock, surrounded by a dense core possibly made of silicates. The presence of significant amounts of ice and water suggests that Ceres may have once held liquid water, especially if its core was warmed by the early decay of radioactive materials. This internal structure sets Ceres apart from the nearby asteroids and prompts intriguing questions about its potential for geological activity and the role water played in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that it may have formed in a colder region of the solar system and later migrated inward. The presence of ammonia is significant because it lowers water's freezing point, supporting the existence of brines on the surface. These insights into the history and composition of Ceres not only enhance our understanding of this remarkable dwarf planet, but also offer valuable information about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and extremely rare geological process, particularly when compared to the more familiar volcanic activity observed on Earth. Unlike conventional molten rock volcanoes, cryovolcanoes expel substances such as water, ammonia, or methane. These substances can exist as gases or liquids in the frigid environments where Ceres cryovolcanoes are found. Cryovolcanoes on Ceres function by allowing salt-laden water to rise to the surface. When this salty water reaches the vacuum of space, it rapidly sublimates, transitioning directly from liquid or solid to gas, resulting in the formation of reflective salt deposits. These enigmatic bright spots on the surface of Ceres are formed by such residues. The most well-known of these spots are located in the Achater crater, also known as 5. This region has attracted significant attention due to its high reflectivity and the periodic hazes observed by NASA's Dawn spacecraft. These hazes are thought to be caused by water sublimation, suggesting that activity may still be ongoing or occurred relatively recently. In addition to the Achater crater, numerous other bright spots, each with unique features, have been identified. These locations are dispersed across the surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright areas underscores Ceres' active and dynamic nature, challenging the assumption that it is a geologically dead world. As the Dawn spacecraft continued to image Ceres, more surface features came into view. Each crater tells a part of the dwarf planet's history. As Dawn progressed into orbit, researchers gained a deeper understanding of Ceres' internal and surface processes. One of the most exciting discoveries was the existence of organic molecules, building blocks of life. In 2017, NASA announced the detection of aliphatic organic compounds in the vicinity of a crater. These carbon-based molecules are often associated with biological activity, though they can also form through abiotic processes. The coexistence of brines and organics, along with evidence of past or present liquid water, suggests that Ceres may once have had, or still maintains, the conditions necessary to support microbial life. Although no life has yet been discovered, the convergence of internal heat and water-based chemistry makes Ceres an appealing target for astrobiological research. From a cultural and historical standpoint, Ceres also holds a special place in astronomy. It was the first object discovered in the asteroid belt and was originally classified as a planet, then an asteroid, and eventually as a dwarf planet. Its evolving classification reflects the growth of astronomical understanding and the development of celestial taxonomy. Scientifically, Ceres offers a preserved record of the early solar system. Unlike larger planets that have undergone extensive geological processing, Ceres has remained relatively unchanged. Studying it gives scientists valuable insights into the conditions that prevailed 4.5 billion years ago and helps in developing theories about planetary formation, migration, and differentiation. Let us know what you think in the comments below. If you enjoyed this, make sure to like the video and subscribe.